Hello everyone and welcome to the second week of microservices using Java and Docker. Before proceeding further, now let's recap what we have learned so far in the previous week. So in the previous week, we have learned about the various application architectures and their advantages and challenges. We saw that how there are various other different architectural patterns which exist and how we can use them for various scenarios. Then we saw how microservices help us to build scalable and reliable applications quickly. We saw how by the nature of the design, microservices helps us to create modular services, which in turn helps us to speed up the application development and also kind of helps us to create the application quickly. Then we saw what is Spring Framework. We saw how Spring Framework helps us to create microservices, and we also saw what are the various projects which are available under the Spring Framework like Spring Boot, Spring Cloud and so on. So we just saw a quick introduction of Spring. The next, we also saw how we can create a sample microservices using Spring Boot and Eclipse IDE. We went to the Spring Initializer website, we downloaded our starter kit, and then we just made a few changes in our local and we got the microservice up and running. So that was pretty much about what we did in the last week. So let's quickly see what we are going to learn in this week. So in this week, we will understand what is cloud native applications. We'll try to understand what is the concept of a cloud native application. Next, we will see what is traditional versus cloud native application comparison. So we will understand that what is the main differences or the main points of differences between a traditional application versus a cloud native application. The third thing that we'll see is we'll understand what is the 12 factor for a cloud native application. So in order to build any microservices or cloud native application, it's important that we understand the 12 factor principle behind it. And also recently there have been 3 additional factors which have been proposed. So technically it is like 12 plus 3 factors, which you will be seeing today. Also, finally, we'll understand the sizing and boundary identification for microservices. So what we mean by this is, since we understand that microservices is composed of multiple services, it is very important for you to understand how can we define or identify the services which has to be created. So this is very important step because before getting into any microservice development, we should understand the scope and know the number of microservices which we are going to create. So the learning objectives of this week is we are going to learn about what is cloud native application. We will understand the differences between the traditional and cloud native application. Then we'll understand the 12 factor for building cloud native application. And finally, we'll understand how can we size and identify the boundaries for microservices. So now let's start our discussion with the concept of cloud native application. So cloud native application, as the name implies, is an application that is created for the cloud and it is resilient, manageable and observable. So let's try to just break it down and understand what we mean by this. So essentially, there are 2 kinds of application which is available. One is the traditional application and one is the cloud native application. So when we mean cloud native application, it means that this application is created from the scratch for the cloud. Okay. So when we say for the cloud, it means that you are not kind of maintaining that application or deploying that application in a physical server or in a virtual server that is kind of present in your company or in your premises. Rather, you're creating it on the cloud, and by that definition or by that concept, it becomes resilient, manageable and observable. So what we mean by resilient is when you deploy anything to the cloud, what happens is there are multiple instances that are spun up on the go because as we saw in the last week, it is important that your application has to be scalable, meaning if 10 users use your application has to be up, and even if there are 10 lakh customers or users of your application, still your application should be able to handle the load. So it is important that the application is kind of resilient to these loads and any other resource demand that comes on it. So when we create a cloud native application, our application becomes resilient because we are using the benefits of cloud and we can spun up new instances of application on the go. Second is manageable. This everything is on the cloud and you're just going to configure the working parts of it or the configuration part of it and not actually manage the server infrastructure and other parts. The application becomes quite manageable. You will have various application properties and configuration properties by which you can easily manage and spin up new instances of application, change the properties and so on. The third is observable. So what we mean by observable is like, you can easily observe what is the status of your application. Like, for example, you will have these various dashboards, logs, and other mechanisms by which you can kind of understand how your application is performing and what is the current status of your entire application. So the next thing that we are going to understand is we'll see like what are the major pillars for the success of cloud native application. So in order to create cloud native application, it's important that you have modern design, you have microservices, you have containers, you have backing services, and you have automations. So when you have all these 5 things in place, then you can say that you have created a cloud native application, right? And what is this cloud infrastructure over here is because ultimately our cloud native application is going to be deployed in a cloud infrastructure. So that's why we say it is a this is the cloud infrastructure. So meaning like you could use any public cloud like Azure, Google, or AWS, or you can also have your private cloud, or you can also use a hybrid model. Let's understand each of these pillars now. So a microservice is an essential ingredient for building a cloud native application. So this is something we saw even in the last week. So we said that microservice is an essential ingredient for building cloud native application. So if you just go back to the previous slide, you see that when we say that we are creating a cloud native application, we say that it has to be composed of these 5 pillars. So one of this is microservice, the others being modern design, containers, backing service, and automation. So what are each of this? We will be seeing it in detail. So as we saw, a microservice is an essential ingredient for building cloud native application. The next is modern design concepts make it simpler to construct and scale applications based on their requirement. So what we mean by a modern design concept? So traditionally what used to happen is like your any application which used to be created used to be kind of like monolithic in design. So wherein like you had these multiple modules or multiple parts of the application being constructed together and just shipped as one single piece of code or software which used to be deployed. And also there weren't like too many best practices around when the software development was actually done in the previous days. So by modern design concepts, it just means like, all the best practices which we have learned over the years, like, trying to make the application modular. You try to separate the concerns. You just ensure that, one function or one class is only doing one activity or one functionality at a time. So all these kind of the modern principles makes it easier for us to kind of scale and construct the application. Why? Because when we create modular classes or modular applications or functionalities, it becomes easy for us to compose an application of multiple independent units, which in turn can then be like scaled up or down based on the requirement. The next is like we have a concept called 12-factor methodology, which is a popular approach for developing cloud native application with the recent inclusion of 3 more components, and thus the name 12 plus 3. So what is this 12 factor is nothing but you can just say like it is kind of a recipe or a guideline for you to create a cloud native applications, right? So it has a few methodologies or guidelines which is suggested in order to create any cloud native applications. The next pillar we saw is container for a cloud native application. So container is nothing but it helps in packaging of the code and dependencies into a runtime called container image, which can be run on any machine having a container runtime. So don't worry if you don't understand what is this container concept. So just to abstract it, we can just imagine it as, just imagine that you have your code is now bundled into a zip or whatever along with all its other dependencies. Now what we do is we just take this code and put it, just abstract it as like a container, which is kind of the runtime or the environment for this code to execute. So what happens is you can just ship this container to any environment. It could be like your Windows machine, Linux machine, like any of the servers that you want to run. And what happens is this container then runs that application within that container such that the entire runtime and environment is standardized, and there is no differences between an application which is running in Windows server versus application which is running in a Linux server. And container helps us to achieve the portability and consistency across any environment and platform. So the advantage is, since you are going to package everything as a container and that container is going to run in a runtime environment, we achieve kind of portability and consistency. The same code behaves the same way across any server or any environment. The next concept which we are going to see is called as backing services. So backing services are nothing but the ancillary services to manage the application listed below. Basically, like whenever we have any monitoring apps or message brokering apps or analytics, we use the concept of backing services. So what is backing service technically is like they are the services which does not implement your business logic, but they are useful in kind of like managing your applications by doing other backend activities like monitoring work or messaging brokering work or analytics works. So the cloud native applications prefer managed backing services from cloud vendors. So what we mean by that is, so if you take any of these commercial cloud vendors like AWS or Azure or GCP, which is Google, so you will see that they already have a lot of services which they provide out of the box. For example, for analytics they have certain services. For monitoring your network they have certain services. If you want to scale up or down or like do some setup and related configuration, they have certain services. So what happens is, generally when we create any cloud native application, we prefer to have these backing services from the cloud vendor itself rather than creating them by ourselves. So the advantage is we reduce the development time, and also since these are being maintained by the cloud vendors, the maintenance and operations from our end also gets reduced. The next part is automation. The next pillar of cloud native application is automation. So automation is nothing but it just refers to the automation of CI/CD process and infrastructure so that we consistently deliver the stable applications, updates, and we can quickly scale without any overheads. So what that means is, as the name suggests, automation, right? So it means that we are just reducing manual activities or manual work. So the first is automation of CI/CD process. So what is the CI/CD process? So assume that you or your team is creating an application and you have completed your code. So once you commit your code into a repository like GitHub, so automatically there should be automation in place that will directly now read this code, perform certain quality checks like SonarLint, SonarQube, there are certain industry best practices where we first check for the code quality, and then once the code quality passes, then we will do we'll check for the unit test cases result, wherein we will see whether if all the unit test cases are passing. And after that, once that is done, we jump into the CD part, wherein once the build file or the war file, jar file is created from the code, we then take those jar file and deploy it to the servers running these applications so that the entire deployment process is completed. So if you take any major enterprises like Amazon, Google, or any of those even enterprises like Uber, Ola and all that, so what happens is every minute there are tens and hundreds of deployments or CI/CD pipelines which are running. So the application that you use on a day-to-day basis, it could be IRCTC, it could be Uber, Ola, so on and so forth. So though you're using the application in the background, there are deployments and other stuff which are running, and but you don't feel it because your application is always up and running, and there are lot of things that goes in the background to ensure that your application is staying constantly updated. And what does the automation of infrastructure means is, there is a concept called as infrastructure as a code, IAC, wherein we script the entire infrastructure so that it can be used to consistently provision infrastructure across any environment. So in order to explain that, let me tell you a simple example. So assume that you want to have a DB server setup, a database server setup in your environment. Okay. So the normal way to do it, you will first download the exe or the installer of the DB server, then you install it, then you configure all the environment, class path and other stuff that is required, username, password, all that thing that is required. And finally, to start your server, you will either use a script or you would invoke certain batch script and all that stuff. But the problem is this is not end-to-end automated. Though you have certain script to start the server, stop the server and all, but there are also certain manual parts attached to it, downloading the installer, executing the installer, so on and so forth. So what infrastructure as code does is, this entire process of right from installing the database server till the point the server is started up or shut down and all that stuff, we will code everything as a script, and we'll just upload it to a container or a server. So on executing this entire end-to-end workflow gets executed, and that is what is the concept of infrastructure as a code. And to implement it, we have a lot of popular tool, we have something called as Terraform, we have something called as Puppet, Ansible, Chef. So all these tools helps us to do it. So now we will just quickly go to the whiteboard and understand all these concepts that we have seen about cloud native application in a bit more detail. So far we have understood, we have discussed about what is a cloud native application, right? So just to quickly summarize, a cloud native application is nothing but it is an application that is designed from the scratch to be implemented in cloud infrastructure, right? And we also saw that, there are certain pillars for cloud native applications. Like we saw it has something called as a modern design. You should have microservices. It should have automation. It should have backing services. And finally, it should have containers. So using all this, we implement cloud native application, right? And also we saw that, there are certain guidelines for implementing cloud native application, which is called as the 12-factor app. And also there are additional 3 factors which got recently proposed. So we can either say it as 15 factors or 12 plus 3, or generally it is called as 12 factors, right? So in this course, the reason why this course is developed is we are now interested in learning this part, the microservices part, where we'll try to understand how can we write microservices, how can we create microservices, and using that it will enable you to create the cloud native design. So the other part, like modern design, automation, backing services and containers, we'll also try to cover it in bits and pieces, like which is required for us to implement our microservices. But largely your focus is now to understand how can we create microservices and how can we implement microservices, right? And also when we be doing it, we'll also be touching about the other pillars as and when we are creating our microservices. So that was a quick summary of what we have seen so far. And now what we'll do is we'll first try to understand how the application development has evolved over time. So this is just a quick summary for you to understand. So in case you're not really aware of how application development used to happen in the previous days, in the older generation, without that you will not be able to appreciate what is the benefit of cloud native application. So we'll quickly try to summarize how the application development was done before the recent period. So in the older days, what used to happen is, so we can just divide the application development phases into 3 eras, right? So one I would say is till the era of maybe early 2000s, okay? Then the era I would say around 2010s, okay? And after that, the recent period of say I would say after 2015s, okay? So I would say I would just divide this era into this 3 eras, okay? This year is not put in it's not very strict sense of definition. But I'm just telling it was around this period that the new concepts came and the design philosophies changed a bit, okay? So in the early in the till the turn of the millennium, that is around 2000, generally the application development used to happen in a waterfall life cycle. So for the people who are not aware of what is a waterfall life cycle, it is a software development life cycle mechanism wherein we follow a certain step procedure in order to create the software. It starts right from the requirement analysis, then you do you try to understand the requirement gathering, then you do analysis, then then you do the development, you do the testing, and finally you deploy the complete software. So here there was no concept of a minimal working software or delivering software in bits and pieces. It was always you deliver the entire software in one go. Say for example, you could just imagine if I had to develop IRCTC in the early 2000. So unless all my functionalities in place, right from booking of my ticket to cancelling my ticket to seeing what trains are available. So unless all these features are fully developed, tested and signed off by the end user, I would not be able to complete the software project. So that was the a waterfall method which was used earlier for the software development. And generally what happened is whenever you developed any application, it was largely monolithic. So as we saw even in the week 1, most of the application that was developed in the earlier days, they were monolithic in nature. And what do you mean by monolithic? Is that everything, all the software components your UI part, your API part, your database part, everything was created in a very tightly coupled fashion, wherein if you change anything on the UI or the front end, it will invariably affect the API, and changing anything in the API would invariably affect the database, and or vice versa. And next, when this application was created, they were deployed into mostly into physical server, okay? So what we mean by physical server is, like, there used to be this big servers or the data centers which the companies used to maintain, and all these applications were actually deployed in these physical servers. Okay. And finally, whenever, like, since your company used to have, like, tons of applications, then obviously you cannot have all the application deployed in one server. So that is why you had this concept of data center, as I just said. So what this data center used to do is, it is nothing but, you can say, a collection of multiple servers running in the center, wherein, like, all your application used to be running there, right? So even today, like, you would have heard that, Google has the data center over here, and, Microsoft has a data center over there, so on and so forth. So data center is nothing but it's just a center where all the servers are located and your applications are running, right? So this was the scenario that used to happen, like, in the early 2000s till early 2000s, I would say. And by what I mean by this is, largely, so, like, I would say, like, almost 90% of all the applications which were developed were following kind of this design. So from the period of, I would say, like, 2000s to, like, late 2010s, what happens is, there is this concept of agile development that took place. So what is agile concept is, rather than, like, creating an entire software from the scratch and then, like, waiting till every feature is completed and then deploying it, agile follows an incremental approach, iterative incremental approach. So what it means by that is, so I'll just give a simple example. So say, assume that, you want to, like, have create a vehicle for your transport purposes. Okay. So what Waterfall said is, unless you had a car or, like, you had a proper vehicle, you cannot ship that product. But rather, in agile, the concept is, if you want to create a transport, you first start with something like a bicycle, right? So you create a bicycle, you test it, get the user feedback, and once the user tells, okay, cycle is good, but it is like, it takes me too much time to pedal. So in the next iteration, what I'll do is, I'll create a motorbike or a scooter, right? So in this iteration, I will create a bike and I'll again deliver it to the user. The user will test it. Then you will say, yes, now the effort part is less, but still, like, I have this probability of falling down, or, like, I have this probability of, like, if there is rain, or, like, the weather is not good, I'm not able to reach the place comfortably. Then finally, what you do, you create a car. Once you create a car, like, again, you go back to the user, get their feedback, you refine the car, so on and so forth. And finally, after, say, some iterations, you will have a car that, like, totally meets the user expectation. So here, if you see, the focus is more on, like, the user feedback and updating your application features step by step. So that is the concept of agile. So what happened is, like, in the late 2010s, in the early 2010s, we kind of used the agile principles more and more in the software development. And once the agile development principle came, there also we started stressing more on modular development. What do you mean by modular development is, instead of, like, having a strict monolithic application where only one team can work, we started to have multiple teams as per that agile methodology. So we started to prefer more like a n-tier architecture. So what is the n-tier architecture is, like, you have a separate server component, you have a separate front-end component, you have a separate DB component, and all of them were kind of acting in layers, right? And later what we did is, instead of, like, deploying each and every application into a physical server, there was this concept of virtual machine. So what happened is, on top of physical server, we installed virtual machines, like we had softwares like VMware, in which we again had, like, multiple OS, basically, like, it's just like virtualization of operating system. So what we did is, inside one physical server, we created 10 different operating systems or virtual operating systems, inside which we can deploy 10 different applications. Okay, so the advantage was, like, earlier we had a like, kind of like a limitations that, we can only deploy a fixed number of application in a physical server. But once you had virtual machine in place, in the same physical server, now you could have or isolate multiple applications which could run in parallel, right? And since we were using this concept of virtual machine, now instead of data center, we moved it into a concept called as hosted platform or a hosted infrastructure. So what that means is, so instead of, like, you kind of owning the physical server or managing the physical server, we could now, like, outsource that part to someone who could do that for us. Like, there were vendors who would be, like, giving you the infrastructure, and you could then use that infrastructure to kind of create your virtual machine and host it. Then later what happened is, from the mid 2015s onwards, what happened is there was this change in the entire software development industry. So what happened is, then we had this software development cycle called as DevOps. So what DevOps basically means is, the developer basically does both the development as well as the operation part. By operation part, we mean the deployment part, maintenance of part, like the unit testing and all that stuff. So everything the developer used to manage, or we could say that there was kind of a continuous link between the developer and the operation team. That is the concept of DevOps. And since DevOps came into place, it automated a lot of mundane or repeated tasks. And right from this NTR and monolithic kind of architectures, we moved into the microservices. Okay. And when I mean NTR in this 2010s, it does not mean that we only had NTRs. We also had other concepts like SOA, which we saw in the last week. So the other architectures which promoted this modular kind of architecture, the NTR, SOA, event driven. So all these kind of architectures were kind of embraced in the early 2010s. But from the 2015s, what happened is, since we had this concept of DevOps in place, and we could automate a lot of mundane tasks, we then moved into this concept of architecture of microservices, where we created a lot of modular microservices. And instead of deploying them into VM or physical servers, we now started shipping them as containers. Okay, so this is where the containers boom came into picture. And now since we have them as container, we started to directly kind of deploy them over cloud. Okay. So if you see due to one thing, the other thing started getting developed. And this is how we now moved into a cloud native architecture or a cloud native applications. So this was just a quick introduction for you to understand how software development came into picture, and how it got evolved over time, and how we reached a spot right now where we could create microservice and automate the end-to-end lifecycle of a application, right from the development till the deployment into cloud. And with that, we have reached the end of this first part. Thank you.